In this video, we're going to do another example on hypothesis testing of the population proportion, and we're going to use data file Eagle. So here's the question. Question number 41. So please give it a read. Here we have a survey, and then they are sending coupons to a sample of 100 credit card customers. They want to see if the customers are using the coupon. And if the at least 10% of those receiving the coupons use them, the program is considered to be a success, right? So they want to see if the promotion program is successful or not. And here is basically a hypothesis testing. The question asks to develop hypotheses that can be used to test whether the population proportion of those who will use the coupons is sufficient to go national. So what does this mean? If the proportion is sufficient to go national, here we have actually the details of this statement. Here it says it's considered if at least or more than 10% of those receiving use those coupons. All right. So basically, we want to test to see if the proportion of people who are going to use it who are going to use the product are actually more than let's say 10% of the population or of the total population of the customers, potential customers. All right. And then we have the data file. We want to, we're going to create a point estimate for population proportion, and then we are going to test the hypothesis that we develop at part A with 5% level of significance. And we basically make the conclusion. So here I have the data file Eagle, and then I'm going to copy the details of hypothesis testing, the formulas for hypothesis testing for the population proportion. All right, so here's the formula. So the first step would be to develop the null and alternative hypothesis. So the null and alternative. So in this question, we are actually given with the alternative. So it's easier to start with the alternative and then form the null hypothesis. So the alternative, we have a research question. We have a claim, a statement that we need a strong proof, a strong evidence for that. So what is that statement? It says the proportion of people who use the coupon is at least 10% or more than 10%. We basically, the claim is whether the promotion is a success or not. And being the success is actually our research question. This is the claim. This is what we need to find evidence for, if the program is successful or not, right? So the positive answer to this, rejecting the null hypothesis, means taking the program as a success. And that is a claim that we want to, that is our research question that we want to answer. So the proportion of people using their coupons, therefore, less than or equal to 10%, that would be the null hypothesis. All right. So this is basically how we develop. And this is, by definition, this looks like this one. And it's an upper tail test. So this is an upper tail test. For this one, For any of these, we need to find the test statistic, which follows a standard normal distribution. So we need P bar, P0. P0 would be hypothetical value for the proportion, and that would be 10%. P bar, we need to find the number of people who said yes to coupon, who used the coupon, and then standard error, and that's it. We can go ahead and find the test statistic and find the p-value, upper limit, upper tail p-value, and then make the conclusion, right? So I'm gonna first set the level of significance, which was 5%. Wait, was it 5%? It says, again, 5%. All right. Level of significance, 5%. And for the test statistic, we need sample proportion of people who said yes. So I'm going to be first find the sample size, response of interest, count of interest, and then sample proportion. Sample proportion, or P bar. Then we need hypothesized value. Hypothesized value for P, which is P0, and it would be 10%. So I just typed 0.1. So we have P0, we have P bar. We can go ahead and find the standard error. Standard error using the hypothesized value. And then we can go ahead and find the test statistic Z, for which we can now go ahead and find the p-value. Lower tail, p-value, upper tail, and p-value two-tailed. And then make the conclusion. All right. So the sample size is going to be count A of the sample, which is 100 users, right? 100, it's a count. Response of interest here in this case is yes. So this is proportion of people who said yes to the coupon. So yes, count of interest, count F, range, column A, criteria, yes. Again, make sure that this yes is exactly the same. You don't want to have extra space or something at the end. 13. So sample proportion out of 100 people surveyed, or in our sample, 13 said they used. So 13 divided by 100, 13%, or 0.13. All right, so now we have a sample proportion that is actually greater than our hypothesized value. Now, the question here, so it's good actually. We're at the upper side of the distribution. If we take 0.1 as the center, 0.13 is at the right side, is at the upper side of the distribution. But now the question is this large enough to go ahead and reject the null hypothesis? So this is what we want to answer. And in order to answer that, we need standard error, which is square root of P0, sample P0, hypothesized value, times 1 minus P0 divided by sample size of 100. And then the test statistic the test statistic would be P bar, parenthesis, P bar, sample proportion minus P0, hypothesized value, divided by the standard error. So just standard error. And we have the test statistic equal to 1. And let's go ahead and find the p-value lower tail, norm.s dot distribution for 1 and true. So that's the p-value lower tail. 1 minus p-value lower tail is p-value upper tail, and 2 times minimum of lower and upper tail. That would give us p-value 2 tail. This is an upper tail type of test, so we just need to get p-value upper tail. We just need to focus on this one for our conclusion purposes. So since this is greater than alpha, we fail to reject the null hypothesis. So we don't have enough evidence to reject this and take this, right? So this means that even though the sample proportion is higher than 10%, but it's not large enough for us to go ahead and reject the null hypothesis, all right? So since p-value is not less than or is greater than alpha, being 5%, since p-value is greater than alpha, we fail to reject the null hypothesis, which means that we're going to conclude, we fail to reject the null hypothesis and conclude with 95% confidence that the proportion of people who use the coupon in the population, right? So we are talking about population proportion of people who use the coupon is, I mean, based on the sample, based on the numbers that we found, we can't say it's greater than 10%. So we cannot take the null hypothesis. So it's not greater than, use the coupon is not statistically greater than. It might be, but given this sample, we couldn't find enough evidence to support that. We may need to take a larger sample, for example. It's not a statistically greater than 10% or 0.10. Since p-value is greater than alpha, we fail to reject the null hypothesis and conclude with 95% confidence that the population proportion of people who use the coupon is not statistically greater than 10%.